We've all been there, right? You ask an AI to write an email, and it does. Pretty cool. But what if it could not just write the email, but also find the recipient's contact info, schedule the follow-up meeting, and add it to your calendar? That's the jump we're talking about today, from chatbots to true AI agents. So yeah, we're pretty used to AIs that can chat and summarize things, but the real revolution, the thing that's going to change everything, is getting them to stop just talking and start doing. We're talking about teaching them to actually interact with the digital world, to learn from it, and to handle complex stuff for us from start to finish.
Okay, so how do we make this happen? How do we go from a talker to a doer? Well, it all comes down to a really cool idea called Agentic Reinforcement Learning, or Agentic RL for short. This is basically the software upgrade that turns a standard LLM, a text generator, into a genuine decision maker. One that can plan things out, use digital tools, and even look back at its own work to figure out how to do better next time.
All right, so here's how we're going to break this all down. First, we'll get into what really makes an agent different from a chatbot. Then we'll look at the totally new way they learn. We'll explore this from a couple of different angles. First, the new powers this gives them, and second, where they're actually being used. And of course, we'll wrap up by looking at the big challenges that are still out there.
Right, so first things first, what's the fundamental difference? Think about it like this. A chatbot is totally passive. You ask it something, it gives you an answer. End of story. An AI agent, on the other hand, is an active participant. It's not just sitting there waiting for your next question. It's built to go out into an environment and get a job done.
And to build an AI that can do that, to make it an active player, you just can't use the same old training methods. It takes a complete shift in how they learn. We're moving beyond just teaching them to predict the next word in a sentence to teaching them how to predict the right action to take next.
I love this analogy. It makes it super clear. The old way of training a chatbot is like a student who's just cramming for a final exam. They're just memorizing a massive, static textbook of human-written data. But the new, agentic way, that's more like a scientist in a lab. The agent is actively running experiments, getting real-time feedback from the world around it, and tweaking its approach based on the results. It's learning by doing, not just by reading.
In this chart, this really drills down into the nitty-gritty. Just look at the action space. A chatbot, it's stuck with just spitting out text. An agent, though, can do that, plus take real actions like using a piece of software. And then check out reward. A chatbot just gets a thumbs up or thumbs down on its final answer. An agent gets feedback every single step of the way. And that is absolutely essential for learning how to handle big, complicated tasks. Okay, so this new way of learning is cool and all, but what does it actually mean? What new superpowers does this give an AI? Let's look at this from our first perspective. What can these agents do that a chatbot wouldn't even know where to start with?
First up, they can plan. And I don't just mean spitting out a simple to-do list. We're talking about real strategic thinking here. It can take a huge, vague goal, like plan a trip to Italy, and break it down into a whole series of logical steps, thinking several moves ahead like a chess player.
Second, and honestly, this is a total game changer, they can use tools. Think about what that means. The AI is no longer just a brain in a jar. It can reach out and use a web browser for research, fire up a code interpreter to crunch some numbers, or interact with other apps to get things done. It's like it has hands to work with in the digital world.
They also have memory. And again, we're not just talking about remembering the last thing you said. This is a real, persistent memory. It keeps track of what worked and what failed on past tasks, so it can learn from its own experience and get smarter over time. It's not starting from scratch every single time.
And the last piece of the puzzle is self-improvement. They can actually reflect on their own performance. They can look back at a task, figure out where they messed up, and learn from that mistake so they don't make it again. It's like having a built-in feedback loop for getting better. So, let's recap. You've got planning, tool use, memory, and self-improvement. That's a pretty powerful combination, right? So now let's switch to our second perspective. Where are we actually seeing these agents in action? Let's look at some real-world use cases.
One of the biggest areas for sure is search and research. And I want to be clear, this is way beyond just typing something into Google. We're talking about agents that can go out on the web by themselves, read through tons of different sources, figure out how it all fits together, and then hand you a finished report. It's basically a tireless research assistant.
Then you've got the world of software engineering. Code agents are a huge deal. They can actually write new code from scratch, hunt down bugs in existing software, and get their hands dirty with really complex engineering problems inside massive code bases.
And it's not just creative stuff. Even in a super rigid field like math, they're being used as reasoning agents. These things can prove complicated theorems and solve problems you'd find in a university course, all by meshing high-level logic with actual number-crunching tools.
So why does any of this matter? What's the big takeaway here? When you put all these pieces together, the planning, the tools, the memory, you don't just have a smarter encyclopedia. What you really have is a potential collaborator, a partner that can help you tackle big, messy, multi-step projects from beginning to end.
Of course, it's not all sunshine and roses. This amazing future isn't just going to happen on its own. Building agents that are actually reliable and effective is, well, it's really, really hard. So, let's wrap up by talking about the biggest obstacles that researchers are trying to figure out right now.
The problems pretty much boil down to two big buckets. First, there's trustworthiness. I mean, how do you make sure an agent is secure and nobody can hijack it? How do you stop it from just making stuff up to complete a task, or even worse, just telling you what it thinks you want to hear? That's a huge problem. And the second bucket is scaling. Training these agents takes a mind-boggling amount of computer power, and just creating the virtual training grounds for them to learn in, that's a massive challenge all by itself.
Which brings us to the final and maybe the most important question of all. As we create AI that doesn't just chat, but actually acts in the world for us, the big question isn't just how smart can it get anymore. The real question is, how do we make sure it's working for us in our best interest? Figuring out the rules of the road for these incredibly powerful new tools, that's the challenge that's going to define the next chapter of AI.